So from 1.2 exercise of the chapter real numbers, first bit, express each of the following numbers as a product of its prime factors. What is the first number is given here? 140. So let us find its prime factors. Let us consider 140. As you know that prime numbers 2, 3, 5, 7 and so on. Let us take the starting number 2 and let's divide. 2, 7, 14, 2 zeros. Next with 2 again it is possible. So 2 3s, 2 5s. Next with 5 table you can check. 5 7, 35, 7 1s, 7. So 140 can be written as a product of primes, that is 2 into 2 into 5 into 7. So here 2 repeated twice, we can write as 2 square into 5 into 7, which is the product of prime numbers. Hence this method is known as expressing the given number as a product of prime factors, in which 156, so it's possible to divide by 2, 2 7 14, 2 8 16. Next with 2 table, as it is an even number, 2 3s 6, 1 left, 2 9s 18. Next with the 3 table it can be 3 3s 3 1s 3, next 3 3s, next 13 1s 13. Therefore 156 can be expressed as 2 into 2 into 3 into 13. So which is equal to 2 square into 3 into 13. Next, if you consider another number third, 3825. As this number is end with the unit digit 5, it can divide with 5. So 5 7s are 35, 3 left 32, 5 6 are 30, 2 left, so 5 5s are 25. Next again it can be divided by 5, 5 1s are 5, 2 left, 5 5s are 25, 5 3s are 15. Next it is end with 3, so we can also divide with 3 5s are 15, 3 1s are. Next 3 17s, 17 3s are 51. Next with 17, 17 1s are 17. So we can write 3825 as, what are they? 5 into 5 into 3 into 3 into 17. So let's write 3 as first. 3 into 3 can be written as 3 square. 5 into 5 can be written as 5 square into 17, which is the required product of prime factors. So now let us divide 5005 by prime factors. So 5 1s, 5 0, 5 0, 5 1s. So let us divide 5005 with 5, 5 1s, 5 0, 5 0, 5 1s. Next with the 7 table let us try. 7 1s, 7, 3 left over, 7 4s are 48, 2 left over, 7 3s are. Now 143 can check with 11, 11 1s, 11, 3 left over, 11 3s, 33. So 13 can be written as 13 1s, 13. Therefore 5005 can be written as 5 into 7 into 11 into 13, which is our required product of prime numbers. Next, fifth problem let us consider, that is 7429. Let us try to divide with 7. Is it possible to divide with 7? Let us check it. 7 1s, 7 0, 7 6 are 42, 7 9s. So it is not possible. So let us check with another number, 17. 17 4s are 68. So here how much left over? 6, 2. So 17 4s are 17 3s are 51. So 17 7s are 119. Now 19 table you can check. 19 into 23 times 19 23. 2 3s 2 3 9s are 27. 3 1s are 3 5. 2 9s are 18. 2 1s are 2 plus 1 3 7 13 carry 1. So 437. So it is 23 also prime number. It is divisible by only one time. 7429 as 17 into 19 into 23. So in order to find its prime factors, we have to apply divisibility rules. So by using prime numbers, whether the given number divisible by the prime factor 2 or 3 or 5 or 7, in the sequence we need to check. Whenever it is not, as it is on odd number, it cannot be divisible by 2. So sum of the digits cannot be divisible by 3, therefore we left that. Like that we tried in this sequence, finally we got that 17 is divisible. With 17 the given number is divisible. So in the same manner we have taken as 19 and 23 and checked, found the finally the product of primes. So in order to find the product of given numbers, their prime factors, everyone has to come to know at least prime numbers between 1 and 100, that they are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. Between 1 and 50, there exist 15. Between 50 to 100, there exist 10. Totally, there exist 25 prime numbers which are useful in order to find their prime factors. Let's find the LCM and HCF of the following integers by using prime factorization method. So what do you mean by prime factorization method? It means given numbers to be written as product of prime numbers as we have done in the first bit. So let's write 12 can be as a product of primes. So what is the prime factors of 12? Let us see here. 2 6 are 12. 2 3s are 12. 3 1s are 3. So it can be expressed as 2 into 2 into 3. Next 15. It can also find by using prime numbers. 3 5s are 15. 5 1s 5. So it can be written as 3 into 5. Next 21. So what are its factors? Let us see here. 21. 3 7s are 21, 7 1s are 7. So it can be expressed as 3 into 7. Therefore, LCM of these numbers, before finding LCM, you can write as 2 square into 3. It is 3 into 5. It is 3 into 7. Okay. So LCM is equal to their highest powers of common numbers. So that is 2 square into 3 into, here is 3, here is the 3, here is the 3, next 5 into next 7. So it can be written as 2 2s are 4 into 3 into 5 into 7. So LCM is the product of the greatest power of each prime factor of the numbers. So consider the greatest power in each numbers. 2 square, 3 with highest power is only 3, 5 with highest power only 5, 7 with highest power 7. Their product is 4, 3, 5, 7. 4 3s are 12, 12 5s are 60, 67 are 420. Now let us find the HCF of given numbers. That is, HCF is nothing but product of the smallest power of each common factor of the given numbers. Especially the factors must be common. That is, what is the common factor? 3. here also 3, here also 3. Only one number is exist as common with least powers. Hence, their HCF is 3. As the given numbers are 17, 23, 29, all are primes. Hence, 17, 23 and 29 are all primes. Therefore, LCM is equal to product of the numbers, product of primes. That can be written as 17 into 23 into 29. 11,339. Now, HCF of primes is 1. As primes are having only 1 as factor, therefore 17, 23 and 29 are co-primes. Let us find the solution of this. LCM, how to find out? See here, 8 can be written as 2 into 2 into 2 as the product of primes. In the same way, 9 can be written as 3 into 3 as the product of prime numbers. Next, 25 can be written as 5 into 5. So let us write this product of primes in a short form, that is 2 cube, this is 3 square and it is 5 square. Are there any factors as common? So there are no common factors. Okay, hence LCM will become as the product of each prime factors as they are relatively primes, which is equal to 2 cube into 3 square into 5 square, nothing but 8 into 9 into 25. 25 8 times 200 into 9 1800. So LCM of the given numbers is 1800. Now we can find their HCF, nothing but highest common factor, which is equal to 1 as the given numbers are relatively primes or co-primes. In order to find the LCM and HCF of given these two numbers 72 and 108, let's find their prime factors with starting prime as 2, 2 3s are 6, 2 6s are 12, 2 18s 36, 2 9s, next 3 3s are, next 3 1s are. In the same manner 108, with 2 table it is possible, 2 5s are, 2 4s are, next 2 27s are, next 3 9s are, 3 3s are, 3 1s are. Continue this finding of prime factors till getting 1, which is not a prime, neither composite even. So 72 can be expressed as 2 into 2 into 2 into 3 into 3. So 2 cube into here 3 repeated twice, it can be expressed as 3 square. And 108 can be written as, here what are the prime numbers you got here? 2 into 2. Here 3 repeated how many times? 1, 2, 3 times. So 3 into 3 into 3. So that is 2 square into 3 cube. Now LCM. What do you mean by LCM? Least common multiple, which is equal to the product of the prime numbers or prime factors having with highest factors. So what are the highest factors here? 2 square, 2 cube. So consider as 2 cube. And 3 square, 3 cube. Consider 3 cube. So 2 cube value is 8. 3 cube value is 27. So let us multiply. 8 7s are 56. Carry 5. 8 2s are 16 plus 5. 2 1 6. Next, HCF, product of primes with least powers. Among these, 2 square is the least power and 3 square is the least power. 2 2s are 4, 3 3s are 9, 4 9s are 36. It is the HCF. Let us find the LCM and HCF of the following two numbers. Let us consider 306 first and find its prime factors. So as the number ends with 6, we can divide this by 2. 2 1s 2, 2 5s, 2 3s. Next, as the number ends with 3, sum of the digits is divisible by 3 and the number is divisible by 3. So we can also divide by 3. 3 5s are 3 1s. Next, 3 17s, 17 1s are 17. Next, 657 by different numbers. You can check it as the number is not even. So we can check it for 3, 6 plus 5, 11, 11 plus 7, 18. So as sum of the digits is 18, we can divide this number by 3. 3 2s are 6, 3 1s are 3. Here 2 left over, 27, 3 9s are 27. Now it is also can be divisible by 3, 3 7s are 21, 3 3s are. As 17, 3 is prime, 73 1s, 73. So 306 is equal to 2 into 3 into 3 into 17. It can be expressed as 2 into 3 square into 17. 657 can be written as 3 into 3 into 73 as the product of 3 square in the exponential form into 73. Now LCM, which is equal to product of all the prime numbers with highest powers. What are the prime numbers here? 2 is there. Highest prime is only power is 1. Next 3 square, here also 3 square can be considered. Next here 17 into here 73. So let's find its a product. 3 3s are 9, 9 2s are 18. 18 into 17 into 73. If you multiply these, you will get this product. Let's find its product. 18 into 17. 17. 7 8s are 56. 7 1s are 7 plus 5, 12. 1 8s are 8. 1 1s are 1. So it can be added 6, 10, 1 carry 306. So it is 306 into 73. Now let us multiply this 306 into 73 as their product. 3 6 are 18, 3 0 0, nothing but 1, 3 3 are 9, 7 6 are 42, 7 0 0, 4, 7 3 are 21. So 8, 3, 13, carry 3 and 2. So it is 23,338, which is our LCM. Now let's find their HCF. What do you mean by HCF? HCF is nothing but product of primes with highest powers. Product of common primes. What are the primes common in this? 2 is not common, 3 is common. So we can write a 3 square with the highest power. 3 square and 3 square, among that 3 square is common. Next 73 is not common, 17 also is not common. Therefore HCF is equal to 3 square, nothing but 9. So LCM of given these two numbers 306 and 657 is 23,338. Their HCF is 9. Let us find the solution of this question. First try to understand the question. Check whether 6 power n can end with the digit 0 for any natural number n. Here given number is 6 power n. Now 6 power n can be expressed as 2 into 3 whole power n. here the prime factors of 6 are 2 and 3. Therefore, it cannot be end with the digit 0. The prime factor 5 along with 2. So 6 power n can't end with the digit 0. See, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. First of all, what do you mean by composite numbers? If any number expressed in the form of product of two numbers, then such numbers are called what? Composite numbers. So here, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. First, what do you mean by composite numbers? If any number expressed as a product of two numbers, then such numbers are called composite numbers. So now let us see that 7 into 11 into 13 plus 13, which equal to 13. Let us take common. 17 into 13, 7 into 11 into 1 plus 1. So which can be written as 13 into some k, where k equal to 7 into 11 into 1 plus 1. Next, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 can be written as, by taking 5 as common, 5 here and here. So 5 of 7 into 6 into 1 into 4 into 3 into 2 into 1 plus 1. So it can be written as 5 of this total number can be taken as some k. So or L we can take, where L is equal to 7 into 6 into 4 into 3 into 2 into 1 plus 1. As given expression written as product of two numbers, hence they are what? Composite numbers. So let us write that statement as given numbers are written as product of two numbers, therefore they are composite numbers.